Hey, hi guys. Um, Today, what we have covered is neural networks, and we went to the details on how neural networks work, how is the equation formed, what is the regularization, optimization, and all that stuff. And then we looked hyperparameter tuning. Well, the we we looked at what are the hyperparameters, but we didn't look at how the hyperparameters can be tuned and stuff. What we'll do, we'll programmatically look at how the hyperparameters can be tuned. We'll take a sample data set and try to put hyperparameter tuning on top of it to see understand more about it. Okay. Matter of fact, objective is to allocate one day where we actually program the whole things. I mean, we'll not program from the scratch, but we'll just use the libraries because libraries are pretty easy, and we'll use ChatGPT to generate the code and then run it just for doing a demo of it. So I think that will be a good recap of what we have learned and what we apply and all that stuff. So it'll be good. We'll do that. And okay, today let's focus on CNN. I started already studying CNN yesterday and a little bit like last 2 days and stuff, which I didn't put it on video, but I'll do it now. I might be studying more, might not be able to watch much, but let's see. Okay. So we're actually watching on YouTube. Um, so this guy quickly explained convolutional neural networks. So I'll brief about my understanding till now because it was actually it should be more focused. I've not done that, but it should be more focused. But this guy has explained it pretty well. And there are three things. One is convolution, padding, and stride. What is CNN? Convolution, padding, and stride. These are the three concepts he has explained. Let's start with CNN. CNN is primarily okay. ANN is artificial neural network. Okay. Now, from there, what is CNN is a convolutional neural network. Artificial neural network, what we do, we have input layer and we have hidden layers, and then we have output layer. We pass the inputs to the hidden layers, and then hidden layers will process them and give an output to the output layer. Okay. Even hidden layers and output layer will have a function, activation function, which will actually give certain output. Okay. Convolution neural networks are nothing but they are specifically designed for image processing purpose as a primary intent. They can be used for other purposes also, but primarily they are for image processing purpose. Um, what does a convolution operation mean? Is my understanding is these are if you take an image of n by n pixel. Usually images nowadays with these high-end cameras on Apple phone and all that stuff, right? So they are we receive huge, pretty big images, correct? So that big image is being fed as input. That means each pixel is one data point, correct? So for to give one image as input to a neural network, you should send all the pixels. Let's assume if you take 1000 into 1000 pixels, that is 1000 length and 1000 width pixels to represent an image, right? Then you have literally 1 million pixels to represent one image. You need to feed in 1 million pixel input data to a neural network and ask it to process it. What happens is it becomes very complex with respect to calculation, computation, and stuff. So, so what happened here in neural networks concept? We inputs are features, right? Like F1, F2, F3, F4, and stuff. In a given image, what happens is, assuming images of same dimension are being given, each pixel actually is a feature. That means literally image is nothing but it has 1 million features. because we don't know which pixel represents what, right? Image need not necessarily means that the face is on the center, right? The face is can be on the corner, on the left, on the right. It could be some edge. There could be a car coming in the edge. So we don't know. There are a lot of things, a lot of detail which could be anywhere in an image. An image can never be defined, right? So every pixel is important, and but processing 1 million pixels or more with higher resolution and stuff we consider is a hard task, right? Agree. So because we can't do it that way, what we do is we kind of go for a like principal component analysis, where we create a feature which is effectively similar to other features, right? So we kind of derive the feature from the existing features, and we use that feature for our features for your algorithm. Convolution neural networks is also on a similar lines, where what you do is quickly, if you can see. So we take a filter like this, and we move that filter on top of the image. This is an image with the 6 by 6 pixels. So you move a filter on top of it, and then you, as he has shown here calculation, you multiply each of these numbers with these matrix numbers and add them up, like 6 into 1, 5 into 1, 7 into 1, plus 9 into 0, 1 into 0, 4 into 0, plus, like that. And you calculate the effective sum of this filter on top of those numbers, and then you derive a new matrix out of it, which is because this is 6 by 6, we're keeping a 3 by 3 on top of it. What happens is these three, again these three, again these three, again these three. So there are four, right? You'll get four. Similarly, this way also four. So it is a 4 by 4 matrix. That's how you get. He gives a formula out of it, but it's okay. So what happens basing on this now? The another point that you need to look at is that filter, right? So if you look at the filter, there are some numbers here: 1 1 1 0 0 0 -1 -1 -1. So this has a significance, but I think we've not yet looked at how do you put numbers here. Like if you, so you should decide what size of the filter you should pick up, what should be the filter's values. Those we should still learn it, but as per this guy, what happens is um, this filter will actually help in deriving the vertical edges. Um, he says these are all vertical edges. That means vertical straight lines. Horizontal or non horizontal is also there, right? So how come this line has come when he says vertical? This is not supposed to come, correct? Not horizontal, vertical should be straight lines. Okay, let's see why it is vertical. And if you use the others filter, it gives you horizontal edges. Yeah. So 1 1 1 -1 -1 -1. So this gives us horizontal edges, is what you're saying. I I think it is more on the first column is being considered. The third column making is reducing it. So If there is a straight line here, and if there is no straight line here, then you'll have some value here. Why is that? What's the logic in this? How does it give vertical edges? See here, what up if you can see the difference? The horizontal lines which are actually kind of parallel to x-axis, those are all reflected here. Here, those are all which are parallel to y-axis has been reflected. But how did it happen is a mystery. What are we doing when we are multiplying and then keeping those numbers one into something one? Something? If these 3 points are some, if it's a vertical straight line, what will happen? These three, like let's say here somewhere vertical straight, this one vertical straight line, these 3 points will have RGB values higher, right, than this ones. When it is higher, multiplying them with 1111 will give a bigger sum, agree, for this pixel. But if this pixel, and let's assume there's a pipe like kind of stuff. So if this is also there, let's take a pipe and then put a filter. Let's say one edge of the pipe is here, one edge of the pipe is here. This will remove this and it will become 0. Two vertical edges, if they are there, it's becoming 0. Then how does he say that it detects all the vertical edges? Most probably, I think that is the reason this the other side of the vertical edges didn't coming up here. But we need to get to the details. So this is open question still. How come this gives vertical edges and this gives horizontal edges? He didn't explain on it much. Let's look at here. So that's with the filters and then how the filters are applied and we calculate something. But the objective is to reduce the whole image from n by n to basing on the filter size, it will become, as you said, n minus f plus 1 and into n minus f plus 1. Okay. Where n is the image size, f is the filter size. Okay. Then that's convolution. So that's why you're reducing the size. But what he says is padding concept. If you observe each box when it goes through it here, not this one. Here, if you see the filter when it is going, see this one box, if you look at it, 1 2 3 are picked, right? So observe the one box alone. Oh, it is gone. Okay. Next time it goes 1, 2, 3, 2, 3, 9. At least the 2 is considered twice. So, whereas 1, as because the filter is going this way, the 1 is being considered only one time. Similarly, the 9 also will be considered only once. See, at the end box 698, this line is considered only for this calculation and it's considered only once. So the influence of the first row of the image and last row of the image on this filter, because we are moving this way, is only once, whereas 1, 2, 3, 2, 3, 9, 2 is coming twice, 2, 3, 9, 398. So 1, 2, 3, 2, 3, 9, 398. This is giving 3 times the effect of 3. So the number of times this particular image pixel is influencing the image, especially the ones on the border, is less, because of which it actually has a it actually has a lower implication on the overall convolution convoluted image that we are creating. Correct. So yeah, as he's seeing here, this particular image, if you look at it, it is coming on 4 times, whereas this image is not coming so many times. So what we do is we do a padding so that the block starts from here, and this image becomes internal image, not the edge, and these edge ones might be considered once or twice, but the internal ones are repeated multiple times. Now if the filter goes, see, this image is on repeated like 4 times. So this padding is called technique is called valid and same padding. So valid padding is where you go without padding. So whereas same convolution padding is where you add padding in a way. Okay, yeah, valid convolution is no padding. Same convolution is where the output of the padding will be giving the same image. But this raises another question, saying the objective itself of doing convolution is to reduce the current image to a smaller size, because the image itself is huge, so you can't use the image as is the concept. So but if you come back to same image direction, it doesn't make sense, right? So but let's see what will happen in the remaining when he explains the remaining details, kind of. Strides are nothing but you are moving 169, and then it becomes 6 9 10, then becomes 9 10 2, 10 to 8 2 8 5, right? This is how you're moving 1 pixel at a time, and then you're moving this filter, right? So that movement of 1 pixel is stride. So if you move 2 pixels, then it is 2 strides, that is 169. It moves here, then 9 10 2, and then it moves here 2 8 5. So what is happening? 6 is being calculated only once, right? So you can actually see, this guy will show you. Strided convolution. So if you do it like this, so this guy is on, so 169, then stride 2, if he takes it, then what happens after 169? The box becomes 1 to 9. See, 9 10 2. 6 is only counted once. And also another problem is this region, because of we might not knowing one. and will become 9. From each put 8, 9, something, something is not there, so the filter can't go down. So 9 so this line will not be effective. That's right. That's the strike. So there are two kinds of pooling that could be done. So that means, again, convolutions is where we are actually applying a filter and we are reducing, we tried reducing the size, or it's not trying reducing the size, we try to actually extract some features basing on the filter that is being applied. And you can apply multiple filters. The objective of convolution is really to identify features. For example, from a given image, list of vertical lines, list of horizontal lines, list of circles. To retrieve all vertical lines, they we use one filter and we extract all the vertical lines and we make it one image. Now, for horizontal lines, we'll make it one image. For all circular pieces, we make one image. So for detecting patterns like this within the image, we are using filters. Filter goes over the image, each using the strides, and and it picks up the corresponding feature, and those features are separated out. So you're breaking down the bigger image into smaller images basing on the specific feature, like vertical lines, straight line, circles, blah blah blah. So how do you pick up filters? How does the filters pick up these lines and stuff? I think we'll learn. That's an open question, we should learn about it. Now the max pooling size is, so what happens, there are two kind of pooling, and if you look at the layers, they are not part of the neural network layers. As I said, they are like pre-processing before giving it to neural networks. Is first the convolution happens and then we can give it to pooling, but it is not mandatory that we need to give it like that. But to reduce the size of the pooling, what we are doing is, usual pattern of the images. If you look at it, if you look at any images, most of the images are having similar pixels in a region. For example, if you take this, um, for example, if you take this watch, this whole, if you think this is an image, the blue color, most of the blue colors are close by, right? So what I'm doing is, a few of these blues, I'm adding them. I'm taking the, if I keep an image like this here on the border, which has this blue color and my skin color and stuff at the border, whichever is the darkest color. For example, if my skin is dark, skin area in that filter is the dominant one, then I'll actually give max pooling and average pooling. Max pooling will give you whichever is the more intensity. So let's say my skin is the more intense one in this particular region. I'll keep my skin color there, and I'll remove the remaining three. Okay. If blue is more intense, then I'll keep the blue. I'll remove the other colors. So what I'm doing, I'm reducing by filter size. I'm reducing those image and replacing it with the darkest color. For example, if you go here, if there is black here, and and the remaining are lighter, it will pick up black and then go by the filter. So what happens, this whole size, I'm reducing it down, and actually I'm picking up whichever is the bright colors there. Those are the bright colors I'm picking it up. So max pooling is to reduce the size of the image. Basing on the filter size, it will reduce by certain amount of size. You can make it a half or whatever, but does it have the level of detail that is there in the initial image? No, it will reduce the level of detail that is there in the initial image. But because we need to reduce the image size, we are doing this. At the same time, what we are doing is, like, if there is a blue color that is distributed like this, out of this whole blues, if you are picking up the maximum blue value there, the blue which is of lower intensity, those will go away. Then what you'll end up is, even though the image size from this is reduced, the blue will become, all the darker blues will be put together, so this will become darker, so the image will become more intense or brighter. So you can actually look at it much better than the previous image. Agree? The size and stuff, it might vary, but the image quality becomes, you it becomes more sharp, because what you're doing is, in a given image, you are removing all the lighter shades one, and the higher shade ones can be retained. But that's max pooling, is where you retain the max intensity one, whereas average pooling is where you average. If you get blue intensity ones, out of the four blue intensity, instead of taking the max and then saying it's very bright, let's say there is only one bright and the other ones are all small, then we take an average to show that this is how it is. So it doesn't really give or make us believe that it's very bright. It says an average, say, or average, this is the brightness of this particular image. So um, again, same question on how do you pick up max or average. One question, pooling. Second is, the we are using a filter here. How do you pick up the filter size? So No parameters involved as in no training, same number of channels in output as input. Mhm. Oh. What is this? Now, so you break it down into 3 by 3 matrix into 2 by 2 of 1, 2, 3, 4, 4 parts. We're breaking it down to 4 parts, and then with 4 parts, we are using passing it through. It's like we're breaking down to 4 parts and we're passing it to 4 neurons. 4 neurons will apply. the with the same weights, they'll apply a linear regression kind of w1x1 plus w2x2 plus w3x3, and with a bias term, and they'll generate. That means we are breaking down a given image based on the filter size. We are breaking it down into so many images, n minus f plus 1. Here it is 3 minus 2 plus 1, that is 2. Uh, 2 into 2, like 4. Um, and the 4 images will in turn be passed through 4 neurons. Technically, that's how it is. Okay. No, no, why? We never do it to I think we'll pause here. Back propagation of books. We should look at it one more time to be more clear on how it is working and stuff. Okay.